Well, 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 what do we have here? Here's what I'm thinking. We should probably go over some of these multiplying radical expression problems. Let me make sure this is on proper. Oh, there we are. Very proper now. What do you say we hit some of the odd ones? You look at number 1, root 12 times root 10. Easy way to do it is you could just multiply them together and then break it down with perfect squares. We've done it 100 times. 12 times 10 is 120. So we can make this root 120. And then we got to break it down with those perfect squares, the numbers that we can square root. So you might look at that and you're like, well, I know 4 goes in there because 4 times 3 is 12. So 4 times 30 would be 120. Right? That's an option. Now the square root of 4 is 2. So we have 2 root 30. Now you do want to check if there are any perfect squares left in 30. So think of perfect squares. You could square root 4, 9, 16, 25. Those are the only ones that are less than 30. None of those go into 30. So we're all done. Woohoo! Yay! 2 root 30. If you look at number 3, we have 3 root 10 times root 2. If it helps, you can think of that as 1 root 2. So remember what we've been saying is you can multiply the numbers outside the radical, just like normal. 3 times 1 is 3. And then the numbers inside the radical, you can multiply those too. 10 times 2 is 20. So we got 3 root 20. And again, we're breaking it down with the perfect squares. The only perfect square that goes into 20 would be 4. It's 4 times 5. All this stuff is next to each other. It's all being multiplied. So when we take the square root of 4, which is 2, we're going to have to multiply it with the 3 that was already out there. So 3 times 2 is 6. Here we got 6 root 5. Look at us. We're just having fun today. All right. Number 5, numero 5. Here we go. On the outside, I got a 3 times 4. 3 times 4 is 12. Inside the radical, we have 2 times 5. That's 10. Are there any perfect squares in 10? Well, let's see. The only ones less than 10 are 4 and 9. So neither of those go into 10. Come on. That was 3 root too easy. Oh, boy. On to number 7, shall we? 6 root 18 times 2 root 6. Now the textbook would have you multiply the 18 with the 6, break it down. That's a lovely idea. I love it. But remember, another idea I gave you is like the square root of 5 times the square root of 5 is just 5. The square root of smiley face times the square root of smiley face is just smiley face. So if you can think of something that goes into both of those radicals, you can do that little trick, and it might just have you working with smaller numbers. So let's try that. Something that goes into 18 and 6 would be 6. So we could make, all right, let's do the 6 times 2 first. That's just 12. Those are handled. Now the root 18, the root 6. 18 we're going to make 6 times 3. And then we have this root 6 over here. So this is kind of everything. The 6 times 2 gave us the 12. Here's our root 18 split with the 6 and 3, and then here's our root 6. So this will allow us to do the trick of the square root of 6 times the square root of 6 is just 6. And then we could bring down the other stuff. We could bring down our 12. We could bring down our root 3. And then we're ready to go. There's no more perfect squares in 3. So 12 times 6 is 72. So we'd have 72 root 3. That's one way that you can do it. Again, if you want to do 6 times 18, it'd be 108. So that would give us 12 root 108. The only reason I don't love that is because then I have to think about 108. What still goes in there? That's a big number for me. It would still work out to this, because 108 is 36 times 3. Square root of 36 is 6. And 12 times 6 root 3 would give us the 72 root 3. That's fine. That's cool. All right, we're looking at 3 root 21, 4 root 7. Again, can we think of something that goes into 21 and 7, even if it's not a perfect square? I don't know, maybe. But let's try this. We got the 3 times 4, we can do that. That's 12. Now, 21 and 7, they have 7 as a common factor. So we can make the 21, we can make that 3 times 7, and then we'll just have this other root 7 from up there. And then we can do our trick. The square root of 7 times the square root of 7 is 7. We can bring down our root 3, we can bring down our 12. This is what we have left. 12 times root 3 times 7. The only other thing we can still do is 12 times 7, which is 84. And then we'll tack on the root 3 behind it. No more perfect squares in 3, so we're all gravy, baby. You could do 21 times 7, so that would give you 12 root 147. And then you have to think of perfect squares that go into 147. Again, it's possible. But it's just easier for my brain when I'm working with smaller numbers like this. Like I could do the 7 times 7 trick. All right, here we go. This is the new stuff now. Woo! Here we go. We have to distribute in this 2 root 6. It's just like we're taking these problems and putting 2 into the same problem. 2 root 6 times 2. You can multiply the regular numbers with the regular numbers, radicals with radicals. So I could do 2 times 2. It's just 4. And then we got the root 6 behind it. 4 root 6. Now we got to do 2 root 6 times 5 root 2. Well, 2 times 5 on the outside is 10. In the radical, 6 times 2 is 12. And we have to break these down because remember, we can't add them or subtract them if they have different radicals. They have to be the exact same. So we take it down with all the perfect squares that we can, and then maybe we can combine them later. 6, there are no perfect squares, so we'll leave that for now. But 12, we did earlier, it was 4 times 3. The square root of 4 is 2, so it's 10 times 2 times root 3, which will give us 20 root 3. That's all we can do to that 10 root 12. So we could bring down the 4 root 6 now, 4 root 6 plus 20 root 3. See if you can combine them. They have different numbers in the radical, so we can't go any further. That would be our final answer. We're having so much fun. All right, that was number 11. How about number 13? Oh my goodness. These are going to be some big old numbers. You could try the smiley face trick. You might not want to here. Who knows? 3 root 15 times 1 root 6. Well, 3 times 1 is 3. 15 times 6 is 90. Cool, we'll come back to that. 3 root 15 times 2 root 5. 3 times 2 is 6. 15 times 5 is 75. They have different numbers in the radical. We can't add them yet. Maybe we can break them down with perfect squares. I wonder which perfect square goes into 9D. Wink. It's 9. 9 times 10. 75, you could have 25 times 3. Here we go, we're ready to party. 3 times square root of 9 is 3. So we have 3 times root 10. We'll mash that up here in a second. Plus, square root of 25 is 5. 6 times 5 times root 3. So on the left side, we have 3 times 3. That's 9 root 10. Over here, 6 times 5 is 30. And we'll bring in the root 3. They have different radicals. Can't combine them anymore. So this would be our final answer. Yes! All right! All right, let's try another one. What do you say? 3 root 5 times 3. Only thing we do there is 3 times 3 is 9. So we have 9 root 5. 3 root 5 times negative 5 root 10. Well, 3 times negative 5 is negative 15. In the radical, 5 times 10 is 50. Break them down with the perfect squares. There are no perfect squares in 5. There is one in 50. It's going to be 25 times 2. So we have 15 times root 25 times root 2. The square root of 25 is 5. So we'd have 15 times 5 times root 2. And 15 times 5 is 75. So that comes out to 75 root 2. We'll bring down the other stuff. 9 root 5 minus 75 root 2. Now they have different numbers in the radicals. We've taken out all the perfect squares, so we're all done. But we're not done having fun, because we're ready to go to number 15. Here we go. And we're having fun. Where's 15? What in the world? Oh, we just did 15. Did we not? Yeah, we just did 15. All right. We're on 17 now. Oh, you can't take me anywhere, guys. Root 2 times 6 root 6. Well, there's an invisible 1 on the outside. 1 times 6 is 6. In the radical, 2 times 6 is 12. Sick. Oh my gosh, we got a smiley face times smiley face. Root 2 times root 2, you could say is the square root of 4, but root 2 times root 2 is just going to end up being regular 2. So now we're going to break down our perfect squares. One that goes into 12 would be 4 times 3. 4 is a perfect square. The square root of 4 is 2, so we have 6 times 2 times root 3. If we just clean that up, 6 times 2 is 12. 12 root 3. We could bring down our plus 2. That's a great answer. Delicious answer. There it is. However, proper form, you should put the radicals at the end usually, so you might see it on the bottom as 2 plus 12 root 3. I'm okay with it as 12 root 3 plus 2, but let's be proper. Yeah? Try to be proper when we can be. 17. How many more do we have left? Oh my. Oh my. Goes up to 25. All right, number 19. Here we go. Let's see what we can get done. 1 root 5 times 2 root 5. 1 times 2 is 2. In the radical, 5 times 5 is 25. Now you could do the smiley face times smiley face trick there, but then it'd be like 2 times square root of 5 times the square root of 5 is 5. So it'd be 2 times 5, which is what we'll get here eventually. But let's come back to that. 1 root 5 times 1 root 2 would be 1 root 10. And you don't need to write the 1 there, but I think that'll help me for my next step. Inside we have 1 root 2 times 2 root 5. That would be 2 root 10. And then last, root 2 times root 2. Let's do it like the first one. Let's make it 1 root 4. That's obnoxious. I'm writing an obnoxious amount of work for that particular spot. All right, here. 2 times square root of 25 is 5. 2 times 5 is 10. Look at the back end. 1 times square root of 4 is 2. 1 times 2 is 2. So that's all I cleaned up so far. So we have 10 plus 1 root 10 plus 2 root 10 plus 2. Now we're looking for some common things that we have some like terms. I could do 10 plus 2 all day, dude. 10 plus 2 is 12. Plus, these are both root 10s. How cute is that? 1 root 10 plus 2 root 10 is 3 root 10. Remember, when you're adding or subtracting, you don't change the number in the radical. Oh my gosh. So that's it, man. Again, I know you're having fun out there. I see you right now. Look at you, just having fun. That kid over there, he doesn't look like he's having very much fun. Too much fun. Calm it down. All right, get serious. Here we go, number 21. 6 root 5 times 2 root 5. 6 times 2, 12, no big deal. In the radical, 5 times 5 is 25. Oh my gosh. Now we got to do 6 root 5 times 4 root 2. Well, 6 times 4 is 24. In the radical, 5 times 2 is 10. Oh my gosh. All right, now we're doing the inside. 1 root 2 times 2 root 5. Well, 1 times 2 is 2. Root 2 times root 5 is root 10. Here we go, last one. 1 root 2 times 4 root 2. 1 times 4 is 4. In the radical, 2 times 2 is 4. There might be some more work to do to that one. 12 root 25. Oh my gosh, the square root of 25 is just 5. So that becomes 12 times 5, which is 60. All right. I know I'm going to have the same thing happening at the back end. 4 times square root of 4 is 2. 4 times 2 is 8. All right, now the middle ones. Let's do another step in this one. We can add them. 24 root 10 plus 2 root 10 is 26 root 10. There are no more perfect squares. So we should probably be done with this answer, right? Box it up, move on to the next. What? We could still combine? Oh, 60 plus 8. You're right. It's so silly. That's 68. And then plus our 26 root 10. Wow. I was almost ready to move on to number 23, but you caught me. You caught me at a good spot. Oh my goodness. Number 23. Wow. Here we go. Here's something I notice. Over here in parentheses, I have 1 root 2 plus 1 root 2. It's kind of unusual. But 1 root 2 plus 1 root 2 would just be 2 root 2. That might be a little bit easier because now it's just one term over there. So we could just distribute this back to the other one. And then we don't have to FOIL. We can just distribute. 2 root 2 times 1 root 2. 2 times 1 is 2. In the radical, 2 times 2 is 4. Sick. Now we got to do 2 root 2 times 1 root 5. Well, 2 times 1 is 2. In the radical, root 2 times root 5 is root 10. Wow. And we're having fun. 2 times the square root of 4, that's 2. And then 2 times 2 is 4. Are there any perfect squares left in 10? Psh, nah. So we'll just bring it down. Plus 2 root 10. So much fun with radicals. It's pretty radical. You guys know that song? I know you do. All right, here we go. I think just one more. Yeah, this is it. Aww. Oh, but I want to do more math. 4 times 3 is 12. Wow. 4 times root 3 is just 4 root 3. Inside 4 root 3 times 3 would be 12 root 3. And then 4 root 3 times root 3 would be 4 root 9. Let's clean some stuff up, huh? Well, 4 root 9, the square root of 9 is 3, so 4 times 3 is 12. Okay, all right. So if I kind of rewrite what we got here, we got 12 plus 4 root 3 plus 12 root 3 would be 16 root 3. And then we have that plus 12 back there. Only one more thing to combine, the 12 plus 12. 24 plus 16 root 3. I'll give you a moment to dry your tears. I know you're devastated that we're all done. You got some evens to do. Try them out, even if they seem difficult.